Thank you. Thank you for the intro. Hi, everyone. Thank you for taking your time for my session. I'll talk about a tool called PDF2Audiobook that allows you to read more PDF books by using the machine learning tools of Google Cloud. I'm Kaz. I'm based in Tokyo, and I'm working at Google for over 9 years. And for the last 5 years, I have been working as a developer advocate of Google Cloud team. And now I'm focusing on the cloud AI projects and also machine learning tools such as TensorFlow and BigQuery ML and so on. Okay, we start the presentation. Okay, in this session, I'd like to cover these topics. First, what is PDF2Audiobook? That is the tool I have created as a demonstration. And I will discuss how it works by using the machine learning tools. And it uses multiple components from the cloud AI. The first, it uses OCR feature of the Vision API, and I've discussed about that. And also another important component I have used for the demonstration is AutoML Tables for layered classification. And so I will discuss what is AutoML Tables and how it works for the layered classification for the documents. Then I'll take a look at how it generates the MP3 audio file by using a text-to-speech for generating speech. And lastly, another important product or functionality I have created for this demonstration is the annotation tool by using the Google Apps. Okay, what is PDF2Audiobook? So I started this project like at the end of the last year, like December last year, because at that time I had too many unread books, and I don't have the books anymore in my bookshelf. I have scanned almost all books as PDF. Now I have too many unread PDF books, and then there were no time to read those PDF books one by one. At the same time, I wanted to lose my weight. So I was looking for some the audiobooks or any good MP3 audio file for learning new things. But if you have any experience on trying those audiobooks, usually those audiobooks technical level is not so high. They are designed to address the beginners or primary level of the machine learning or deep learning or any other technical area. So I really wanted to read the latest PDF papers or read the latest PDF books for the deep learning or the machine learning. So I was wondering how I can convert those PDF the books into the audiobooks. So let's take a look at how the tool works. So actually, I haven't created any good. Let me pause the video. So I haven't created any user interface for this tool because this isn't just a simple demonstration. So instead, I'm using the plain Google Cloud Console. So if you go to the Google Cloud Storage user interface, there's a browser of the storage bucket. And if you upload the PDF file on the bucket for this project, then it will start the cloud function processing inside it. And after like 15 minutes, you would get a bunch of like maybe 3 or 4 or 5 MP3 files that is generated from the PDF book. So that's how it works. Let me continue. So this is the generated MP3 files. I'm not sure if you are hearing the audio in this video, but it's playing the Japanese reading voice for that text. So this is how it works. And it is totally based on the cloud functions. This is a serverless environment provided as a Google Cloud service. And it's all, they call it as a function as a service. So instead of the, letting you managing the whole the virtual machines, or letting you installing the whole the software stack on the virtual machines, like installing the JVM or installing the Go runtime, everything's, and manage everything by yourself. You can let the cloud function service to manage the infrastructure, so you don't have to be aware of how many instances you may want to have, or you don't have to manage the life cycle of those the runtimes, instances, virtual machines at all. All you have to do is write some Python code, or maybe Java code, or any Node.js code, and upload to the cloud functions. And as each function gets a new request that is mapped to a new instance, and automatically scaling out, so that if you're getting more and more requests for single functions, you will have the multiple instances or many instances with that particular function. And then, all the lifecycle management is taken care by the environment. So this is the benefit of the managed services. So I thought the cloud function is the best tool for this purpose, because it's not a full-fledged production system. I just wanted to build a demonstration for my personal project. So the cloud function could be also a very useful tool for this kind of prototyping or small-scale based system. So this is the first function I have written for registering a single function called P2A DCS trigger to the cloud functions. I have used the Python code to control everything, and I have defined this function P2A. P2A stands for the PDF2 audio. The P2A DCS trigger function will be called from the runtime whenever it detects a new PDF files uploaded to the certain specified Google Cloud bucket. So you will get the file name, and also the context, the parameters passed to the function. And we don't need to use the context parameter. You can just check the file parameter to get the bucket object and the file blob object. And as you can see on the code I had to write the while loop inside it, because I found sometimes it fails to get the bucket object from the parameters. Somehow it should be, by definitions, the file parameter should have the proper bucket object and the file object, but somehow in reality, some cases the bucket object could be none. So in that case, I would repeat trying reading the bucket name and file blob from that. But anyway, so in the end, it will get the blob object and the file name, so that it's ready to start processing initiating the OCR processing with the Vision API. And after defining this function, you have to register this function as a CRUD function on the runtime. So this is the command I have used to register this function. The CRUD functions deploy, and you can specify the name of the Python function. And as you can see, I had to add just a couple of the other options. And the runtime Python 3.7. This is the standard in the Python runtime. And also, if you want to have the function called whenever you have the object stored on a certain Google Cloud's bucket, Google Cloud storage bucket, then you have to specify this option, trigger bucket option, so that you can specify the bucket name, and whenever the bucket has a new object stored on it, then this function will be called back. And also, I found for the image processing, Yeah, I was using Ghost script for rendering the PDF file into the JPEG file for the annotation tools that I will talk about later. I had to extend the memory space for this particular function runtime up to 2 GB, which is I think the largest the memory you could have on a single CRUD function. And also because it takes sometimes long time for converting the text into the MP3 audio file. So I set the timer to the maximum limit, 540 seconds. And then you can go to the Google Cloud Console to make sure that the function is registered properly. You can go to the console for the cloud functions, and then you can find P2A PCS trigger properly registered. This can be a console or dashboard for these particular functions where you can check out all the number of the requests it has processed and how many errors it got and so on. And also you can click the view logs tabs to move to the Google Cloud Operations, Google Cloud logging feature, where you can check out all the outputs from the logging features. So you can watch out all the errors or all the info level, the logs stored on the Google Cloud logging. And then I have started writing the inside of the functions. Inside of the cloud functions, I have added roughly 4 functions. One is the OCR with Vision API, and then pass the converted text to the feature extraction by AutoML Tables. I have used the AutoML Tables for the layout classification. Then they pass the result to the text-to-speech API for speech synthesis. So let's take a look at each component one by one. OCR with Vision API. So Vision API is the machine learning API provided with the Cloud AI service of Google Cloud. And this is one of the easiest API you can get started with the Cloud AI, because you don't have to train your own machine learning from scratch. Instead, it provides the pre-trained machine learning model for the vision recognition. And also, you don't even have to have the expertise or knowledge of the machine learning. You can just call the API and pass some image file, like a JPEG file or PNG file, to the API. So you'll be getting the result in the JSON format that contains the labels of the objects that is detected in the images you have passed. So it's so easy to get started. And in this case, I have used the OCR feature of the API. The Vision API has multiple functionalities, like object detection or labeling, or what's the dominant color used in the image, or whether the image could be harmful for the children or things like that. But in this case, I have used the OCR, converting the text images into the text strings. So as you can see, if you pass the PDF file, you can take the PDF file or PNG file or any other images. And so if you pass the PDF file to the OCR or Vision API, you would get the JSON result that captures the structures like the images you are seeing right now. So that JSON result captures all the structures of the paragraph and the block in the page. So each paragraph has the characters inside it, and so on. So the JSON will be like this. So you can specify the what kind of the functionality you want to execute for the Vision API. There are multiple functionalities like landmark detection, face detection, object localization, and so on. And in this case, I have specified text detection. And then you would get the response like the JSON file you are seeing on the right side. there will be all the bounding box informations with the X and Y coordinates and so on. And after getting to call this API, I have written a short, small number of the lines of Python code like this one. So in the initial part of this Python code, I have specified the bucket name of the Google Cloud Storage and also the PDF file block name, block object. And also I have specified the features you want to detect. Text, in this case, it's a document text for OCR. And I have specified the MIME type of the file because I was uploading the PDF file, so the MIME type should be an application/PDF. Then you can also specify the output configuration. I have specified the destination URI on the Google Cloud Storage, and I think that's it. Yeah, this is the mainly for the specifying the location of the destination Google Cloud Storage bucket and so on, and the output file name. Lastly, you can call the API. So you can pass those configuration, input configuration and output configuration, and pass it to the client API that is provided with the Vision API. So you don't have to build the raw JSON text file by yourself. Instead, you can use the Python client API for calling the Vision API. So, so you would get all the OCR result with the JSON result. But the problem is that there are unnecessary text included in the result. And the purpose of this project is to generate the PDF file into the audiobook. But while you are hearing to the listening to the audiobook, you may don't want to listen to the unnecessary text like page headers or diagram labels with the small captions and labels in the diagrams, or long URLs embedded in the text, or the page numbers in each page footers. So I really wanted to remove those garbages, and I just really wanted to extract the body or maybe headers of each sections and convert them into the MP3 audio. So that's the reason why I combined I have combined the AutoML tables into this tool for the layered classification. So what is AutoML tables? This is one of the AutoML products provided with the Google Cloud AI platform. And there are multiple AutoML products like AutoML Vision or AutoML, what else? Video, and AutoML Natural Language, and what else? And so on. So, for example, AutoML Vision allows you to train your own customized machine learning model with your specified machine learning image training dataset. So, for example, if you are using the Vision API that I have explained in the previous section, because it's a pre-trained model, so you cannot customize the model. For example, if you want to use the machine learning for detecting some the product on a belt conveyor in your factory, but Vision API doesn't recognize your product because it's not trained with your product's the images. Instead, you may want to use the AutoML Vision to train your own customized model for the object detection. For example, you can prepare for like 5,000 or maybe 10,000 images of your product. It can be anything like consumer products or food items or fashion items or maybe the part, electronics parts, anything. But anyway, so if you are able to prepare for the training image data, then you can train the model with the AutoML Vision. And just like that, with AutoML tables, you can train your own machine learning model with the table data, like tables in a Google Sheet, tabular data like a Google Sheet or Excel spreadsheet, or any tables in any databases like Oracle, MySQL, PostgreSQL. They can be exported as a CSV file and can be imported with the AutoML tables to train your own model. for applying the machine learning, like a classification or regression. And usually, if you want to do something smart thing with the machine learning model for your tabular data, like a tables on a databases or Excel spreadsheet, then you have to hire a data scientist, or maybe you have to read some data science books to do things like this one. You have to define what is the data schema you want to import. You have to apply some pre-processing against the raw data. Usually, the raw data has some things to be cleaned up. You have to do the data cleansing. If there's any outliers or if there's any missing data, missing values, you have to do some, filling the missing the values or removing the outlier data or that kind of the data cleansing is required. And also, if you take a look, if you are learning the basics of the machine learning, you may remember that many things are required for the pre-processing part, like a standardization or the normalization of the data, the pre-processing. If it's on the vision data or image data, you have to do the data augmentation and so on. So that you can get started with the train the model by the neural network model or the simple linear model and so on. With the feature engineering, model selection, hyperparameter tuning, and so on. This is their major tasks for the data scientist. And evaluate the model if it provides the proper accuracy for your purpose, and deploy the model for the scalable prediction service. But anyway, it takes a long time and much expertise to do this if you do have any useful tools like AutoML Tables. But with AutoML Tables, we try to automate a major part of these tedious, time-consuming tasks for the data scientist, defining the database schema and data types of each feature, or what kind of the pre-processing or cleansing is required for each features, and what kind of the feature engineering is required, and what would be the best model for training this model, and how hyperparameter tuning should be conducted. The major part of this tedious task is the half automated, not fully automated, but half automated with AutoML Tables. And behind the scenes, the AutoML Tables is backed with the latest state-of-the-art meta learning technologies the Google research team has created. For example, every training process you would invoke with AutoML Tables it would run the multiple instances for parallel machine learning training, like by using the 50 or maybe up to 90 multiple parallel training jobs running in parallel, so that you'll be able to find the best selection of the hyperparameters or best selection of the model topology design, and combining them by using the debugging ensemble. The debugging ensemble, or simply ensemble, is the popular techniques for the data scientists for combining the best part or best characteristic of the multiple models, like a neural network or a linear model, and so on. And it's quite popular in the data science world, like a Kaggle competition. But you don't have to learn those things from scratch because AutoML Tables can take care of those assembling or hyperparameter tuning and the best model selection automatically. So that's the very short description of what AutoML Tables. In short, it's a kind of the automated data scientist, AI data scientist for you. It doesn't replace it cannot replace the whole part of the human data science, but you can utilize the AutoML Tables as a very powerful tool for shortening the time and cost for data science, data analytics. So if you even don't have any cutting edge knowledge for the data science, you can easily get started with the data science by using the AutoML Tables. And in this particular project, I have used AutoML Tables for the layer detection by using those features you are seeing on this screen. So with the OCR, you would get all the body text of each paragraph. And also that means you can also have the other features such as the number of the characters in each paragraph. And also I have prepared for the other useful features that could be helpful for the AutoML tables for detecting the layout of the documents. The other features include such as the things like the width of each paragraph, or height of each paragraph, or the character size. Because you have the area, the size of the area of each paragraph, if you divide the area with the number of the characters, you can automatically get the character size, whether it's printed in a bigger font or printed with the smaller font. If it's on the header, capital header, the character size should be larger. So I thought this could be an important feature for detecting whether it's a header or the body text. And also the position of the paragraph itself in the x-axis and y-axis, and aspect ratio of the paragraph, whether it's this kind of the vertical paragraph or the horizontal paragraph and so on, and the layout of each paragraph, horizontal or vertical. So I have prepared for these the possible features generated from the OCR result and put them into the AutoML text, AutoML tables with the target label. The target label is the classification label that AutoML tables models should predict. So I have defined, I think this in this case, 4 different labels. If it's just on the plain body text, it should be body. Yeah, body is the name of the label. And if it's section header with the bigger font, it should be a header. And also I have defined some other labels such as caption for the diagram captions. And I have defined the fourth label as other. Other means the garbage text for me. Any unnecessary text that should not be read with included in the audiobook, like the page numbers or page footers, or the small labels attached included in the diagrams and so on. So let's take a look at how the AutoML tables works for this purpose. So you can specify the name of the new data set, and you can specify the data source, URI of the Google Cloud Storage, or maybe a BigQuery query. In this case, I have specified the bucket name of the Google Cloud Storage, so that now your the training data on the Google Cloud Storage is being imported. It takes like a couple of minutes, a couple of tens of minutes, and then it shows the. Let me stop the video for that. Then after reading the training data from Google Cloud Storage, as you can see on the screen, it tries to detect the data types of each column, or each feature. For example, it can detect whether a feature is a numeric column, or whether it's a text column, or it's some categorical column, and so on. And sometimes it makes mistakes. So the humans have to watch out whether each column is properly detected, and you have to correct if needed. And also you can always watch the statistic values, like the counts of each features, how many missing values in each columns, what's the cardinality of each column, or what's the minimum value and maximum value and median or the mean value of each column, and so on. So by looking at the statistic value, you can find out whether this training data could be a kind of healthy training data for getting better machine learning model. Because this is a machine learning, you have to care about the quality of the training data. And AutoML tables allows you to visualize the statistical values, and also the healthy of the training data, and determine whether it's it has enough quality for the training or not. And lastly, you can specify the target column. And in this case, I have specified the target column as target column. Okay. And you can press the train model button. And you can specify the upper limit of the budget. Usually it takes like 4 hours or maybe 6 hours, and it would cost if it's an usually it would cost like a $50, not $1,000, $50 or maybe $100 each time, and you have to wait for like 6 hours. So after finishing the training, you would see the report like this on the evaluate tab. So it reports all the accuracies you would get with this trained model, and also the ROC curve like this one. And also you can also have the confusion matrix for each levels. As you can see, the model generated with the AutoML tables can detect the body text at the accuracy of the 95%. This is not bad. So yeah, I thought by looking at this one, I thought this demonstration can work for my purpose. And also, if you take a look at the numbers for the other, that means this model can detect whether one paragraph could be an other text or not. Like the header, page headers, or page numbers, or URLs, or so on. Those garbage text can be removed at the accuracy of 97%. And also, AutoML Tables provides the feature importance the bar charts. And by taking a look at this, you can learn what are the important features or columns for determining the types of each paragraph. In this case, apparently AutoML Tables uses the text column, the text strings in the OCL text itself is the most important the feature. This is because the AutoML Tables has the natural language processing feature inside it. So it tries to understand the difference of the text strings. For example, if your single paragraph contains the natural languages with the multiple sentences with English text or maybe Japanese text and so on, maybe it looks like a natural body paragraph for that for the machine learning model. Instead, it contains many just symbols that doesn't make any meanings, or URLs, or just numbers and so on. Then this model can detect, oh, this should not be the natural language. This should be just some garbage text. So this is the reason why the text column has the most important, the highest importance. And also there are some other columns like height and width, number of charts. Those are used for determining the types of the paragraphs. So to call this AutoML tables models, so I have written some Python code like this one. Again, you have to specify some input configuration and output configuration. In this case, I have just specified the URI of the Google Cloud storage for the input data and output data, and call the API with the client API. Lastly, you can use this text-to-speech API to generate this speech. This is another pre-trained model from the Cloud AI, so that you don't have to have any knowledge about speech synthesis technology with the machine learning. You can just pass the text with any languages, like the English languages or Japanese languages, so that it can generate the generated English voice or Japanese voice and so on. And in this case, I have added some Ssml tags. I forgot what Ssml stands for, but it's a markup language specifically for the specifying the structure of the speech text. Like this is the one paragraph for speech text, or this is a header for speech text, or I want to put some pause while it is reading this text and so on. So by specifying those SSML, you can make some pause between each paragraph or each section. And yeah, then lastly, I specified the languages of the generated speech voice. or the gender of the voice, and code the API. That's it. So that you would get the MP3 file generated on the Google Cloud Storage. And lastly, I spent so much time on building an annotation tool, because while I was creating the training data, it took like 2 or 3 hours per book, and I had to process like totally I processed like 10 books or 11 books. But after a couple of books, I stopped the making the annotation data, training data, and started to build an annotation tool. Because, by using the Google Sheet for, putting those labels on each paragraph manually, it's so boring and time consuming, and I couldn't do it anymore. So instead, I have created the annotation tools with the Google Apps script with the Google graphical user interface like this one. Let's take a look at how it works. So it reads the OCR result and shows the PDF images, and also shows each paragraph as a rectangle. And by clicking each rectangle, you can change the color that represents the labels for each paragraph, so that you can easily find out the mislabeling part. And these colors is pre-filled with the pre-prediction result from the existing AutoML Tables model. So even though your AutoML Tables model is not smart enough to predict the each paragraph correctly, but you can still get some result, and you can correct that with the annotation tool. That is so-called the semi-supervised learning or active learning. So by using this the annotation tool, I was able to build the active learning or semi-supervised learning setup. And I have written many app script codes to create the user interface with buttons and labels with the DOM, like this one. And also so that I was able to get much higher productivity for the annotation or preparing the training data. So as I mentioned, all the paragraphs should be pre-labeled by using the existing AutoML tables. So by repeating the training of the AutoML tables models, it can get much smarter and smarter every time. That is so-called active learning. And the tool was so easy to build because I have used Google Apps script that is available freely. And the result is the 10 times better productivity. Now, by using this tool, it only takes 15 minutes per book compared with the 2 or 3 hours per book. So that was the topics I wanted to cover. So I have used the OCR from Cloud Vision, and I have used the AutoML Tables for extracting features from the OCR result for the layout classification to determine whether each paragraph could be in body text or caption, header, or the other garbage text that should be removed from the generated audio. And then I have used the text-to-speech voice generation with the high-quality the voice synthesis. If you're interested, please take a look at the product pages for the Cloud Functions, Vision API, and so on. And also, I have published all the source code I have written with my GitHub repository. And sorry that I haven't added any useful comments on that, but maybe you can take a look at how it works. So that's it. Thank you so much. So any questions, please write it on the chat room.